So in this video, we're going to use fences to identify outliers in a box whisker plot. Well, that means adding a lot more detail to our box whisker plot. Previously, we saw that the box was made up of the lower quartile, the upper quartile, they're the hinges, and the median is the 50th percentile. It's right in the middle. So we have the first quartile, which is the 25th percentile, Q3, the 75th percentile, and now we've added these whiskers. The whiskers go from the box to the lower whisker goes from the box to the minimum value. And I'll clarify that in a moment because we have outliers. But typically, the upper whisker goes from the box, Q3, to the maximum value. And it's in quotes because we do have to clarify that when there are outliers present. So we do have outliers. We have two low outliers, and they're designated by two dots that are on the low end of the box whisker plot. And we have two outliers on the high end that are above the upper end of the box plot. So how do we determine whether a data value, is an outlier? Well, there's a quantitative way to do that. And the way statisticians have decided is you calculate a lower fence. And if your data value is smaller than your lower fence, then it's an outlier. What is the lower fence calculation? It is take Q1, subtract 1.5 times the IQR, and that is the lower fence. It's a numerical value. If your data is below that numerical value, which is called the lower fence, it is an outlier. Let me tell you, the fences do not appear in the box whisker plot. They are a mathematical calculation that helps you decide whether something is an outlier. What about outliers on the high end? It's a similar calculation. You take Q3 and you add 1.5 IQRs. And that creates an upper fence, and if it's above the upper fence, it's a high outlier. The fences are not part of the box plot. In fact, we have to modify where the whisker goes. If there are outliers, it goes to the largest value that's not an outlier. This whisker extends to the smallest value that's not an outlier. So I wanted to give you an idea what a box whisker plot looks like in the tool that we're going to be using to create box plots and identify outliers. And that is StatCrunch. That is going to be our tool to do all of our calculations and all of our graphing in this course. What I did is I uploaded a data file that I've used a lot. It's called Mass Data, that has data on lots of variables on school system across the state of Massachusetts. One of the variables is the average math SAT score. And I'm going to use that data file imported into StatCrunch to analyze this variable math SAT scores. So this is what the box whisker plot looks like in StatCrunch. It graphs both the mean and the median. However, that is just a feature of StatCrunch because StatCrunch typically only graphs the median. So it tells you there are 4 outliers in SAT math scores, that the IQR of these SAT scores is 50. It tells you what Q1 is. It tells you what Q3 is. And this lower limit and upper limit isn't really relevant. It's not the fences. So you can get Q1 right off of the output in StatCrunch for the lower fence. You can get the IQR 50 right of the output. So that gives you the ability to calculate the lower fence just from your StatCrunch output. You have to do that by hand. Upper fence, Q3, 1.5 times the interquartile range. Subtract to get the lower fence, add to get the upper fence. So we have these upper and lower fences. It says if a math SAT score is less than 423, it's a low outlier. And you can put little pink boxes around these in StatCrunch, and you can actually find out what the values of these outliers are and what the corresponding cities and towns are. So that's it for now. I hope this helps, and I'll see you later.